everybody, and welcome to the latest installment of This Week in Science. And yes, we are coming in here a little bit later than even our usual lateness because we've got a little bit of, Justin on a cell phone this week. We're doing what we can. We're here. You're here. Thank you for being here. This is This Week in Science. We're going to have a show now. I just want to let all of you know, as you hopefully do know by now, that this is the live recording of our podcast. This is being broadcast and it's live. So, things happen, like us being late. And I don't know, we'll see what happens. But some of those things may be edited from the final podcast. So if you want to get the cleaned up, edited version, wait for the podcast. It'll come out tomorrow. Yes, the podcast.
While we're doing this little preamble, let's ask the audience if there's an echo, because I'm afraid that the speaker and the microphone could be picking each other up, but I don't know if that's true. So when you talk, is there an echo?
So far, so good. I'm not hearing you. Are you hearing
I don't hear anything either.
Perfect. Cool.
All right. We're all here. Hi, all. Yeah. Woo. Let's do this show. Yeah. Make sure to give us the hearts and the likes and the thumbs up and all those things, because that helps us get into the algorithms. Subscribe. We're going to go live now. And it's time. We are live, but now we're going to actually start the recording time. But I'll stop.
Show begin.
Oh, hey, you. Yes. Seriousness. In all seriousness, this show will begin in 3, 2. This is TWIS. This Week in Science, episode number 906, recorded on Wednesday, December 21st, 2022. This Week in Science, top 11 of 2022. Hey everyone, I'm Dr. Kiki, and tonight on the show, we will fill your head with a list full of science. But first,
Disclaimer. Time goes by so fast. Blink, and you won't miss much. It goes by slower than that. But as each day ends, another begins pretty much right away. Pace is relentless. And in the world of science, that relentless pace leads to an abundance of new discoveries. Each year, we attempt to share with you the research highlights, several hundred stories of sciencey goodness, stuffed into a podcast stocking hung on every Wednesday with care. And every year around this time, we pluck out 11 stories that we think are the most interesting of all. And remember, the year that was is soon to be no more. That and reminisce with us for a while here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
and a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of TWIS. We are here actually not doing just another episode. This is one of our special holiday yearly endeavors into the year past. We are looking back at the year that we've just experienced so that we can all be reminded of some of those fun stories, the important stories. We're not going to talk about the boring stories, but we never do. So let's get into it. Blair and Justin, thank you so much for joining me once again for this very special, auspicious occasion.
It's this year in science instead of this week in science.
That's right.
But isn't that a different show?
No.
I guess. It's this show right now.
Oh, okay. Oh, yeah.
Yeah.
It's this
Yeah.
It's the episode. Yes, this is the episode before you. And welcome everyone to this wonderful episode of This Week in Science. We hope that you are here with lots of holiday cheer to endeavor with us down memory lane. Now, Justin, why is it top 11 again?
Well, it used to be a top 10, but then
Right.
we would get all of these phone calls and emails, people asking us, well, what would have been the number 11? Was it this? Was it that? Everybody was so curious. So we added the 11th one on so that nobody would bother us. Although I have received a few emails asking what the 12th one would have been. So it seems to be an ongoing problem. We might have to add one.
Cycle. Yeah.
We'll just keep adding more to the list. Here
Just every decade, we'll add another one. It's fine.
We're just going to talk about all the stuff. There we go. I mean, and really, when we talk about our top stories and top in science from the past year, it's more of the top topics in science. Very rarely does it come down to just one particular finding, because as we know, science is built on the shoulders of giants, right? Everything is a collaboration. Everything is based on what came before. And so very often one study is not, it's great, that's awesome, but it's not necessarily the one thing that's going to change the world. There are other things that have happened. So really, we're going to talk about a lot more than 11 stories. We're going to talk about 11 of our favorite big topics from the year. And so as we jump into the show here, I do want to remind you all that if you are not yet subscribed to us as a podcast, we are found all places podcasts are found. Just go look for This Week in Science or TWIS. You can also find us streaming live weekly Wednesdays at 8 p.m.-ish Pacific time on Facebook, YouTube, and Twitch. We are TWIS Science on Twitch and Twitter and Instagram, and now on Mastodon. But I don't remember what server I signed up for, so it's on there somewhere.
Does that matter?
There we
Because
go.
then
It does.
is it a bunch of little mastodons that you'd have to
Baby.
pick the right
Little
one?
babies.
I don't
It's
get it.
It's
I
a
don't get how the
federated
internet networks.
universe, Justin. We're learning as we go. But yes, we are now TWIS Science on Mastodon. And if all of this is just too much for you to remember right now, just go to twis.org. That's where our show notes are, our links to past shows and subscriptions and all of our social media stuff. So, are we ready to dig in?
Yes.
Let's do it.
Yes. We will start the countdown at number 11.
11. 11. Number 11 this year is climate change. It's got to be on the list. We talked about it, I do believe, every single week, the entire year.
Yep.
But I would say it's not further up on the list just because I don't know if there were any great scientific breakthroughs that we were super blown away about. Just lots of bad news for the most part. We hit 420 parts per million in the atmosphere for carbon. Fish are in trouble. Some fish are going to be okay, but lots of fish are in trouble. Birds are in trouble. Bugs are in trouble. We reported on all that. The Siberian Peninsula is the hottest it's been for 7,000 years. Droughts, all sorts of stuff like that. There were a couple kind of silver lining things we reported on the show. One is that Americans, on the whole, are excited about climate action and want to put climate action forward. The caveat was most Americans think most Americans don't want that. So
yeah, that was an interesting find. Like,
yeah,
they thought their idea was unpopular.
Yeah, we need to talk more about it. Yeah.
Well, and that probably just is reflecting because it seems like a really important thing, but it's never in the news. It's not talked about on any of the cable national news networks.
Well,
they almost don't mention it.
We also reported this year that the president of the United States had a State of the Union. He mentioned climate change twice. We would have liked more. But hey, not that many years ago, it wasn't discussed at all in the presidential debates for the entire presidential run. So there's definitely progress. But what we've learned is it's bad. We need to talk about it more. But as Kiki reported one week, we need to keep solutions in mind and give people hope, because otherwise there's no point in fixing things. So hopefully we'll see some better news in the future. Guaranteed climate change will be talked about a lot next year. But hopefully we'll have some really cool solutions and some policy changes to talk about too.
I can hopefully, but I always have to counter this because I don't want people to be too hopeful. I don't want them to be hopeful to the point of thinking.
So it's I have a handwritten sign in my office that says it's good, it's real, it's bad, it's us, there's hope.
Mhm.
So
Yeah, and I think that's the big trick here is trying to get news, big media to cover it in that way. Yes, everybody knows it's here. Everybody wants to talk about it. We all agree about it. And what can we do about it? What are the big steps to take? What are the things that we're understanding about it? Like fossil fuel companies. Just I think today there's a report that the first lawsuit going against propaganda spread by fossil fuel companies has been put into play. So really naming fossil fuel companies and their efforts to cause disinformation and basically lead, to the propaganda that has led us to be basically a couple of decades behind in our efforts to do anything. So
well, and because
legal systems
ultimately
are working, scientists are working, technology is working, we're all doing this. We just got to keep doing it.
And we talk about it like it's a tomorrow problem, but more and more the science are reporting it's a now and yesterday problem. We are seeing the effects now of climate change from 10, even 20 years ago. So I'm really hoping this is great news. I love to hear that there being some actual accountability.
Yeah.
Here's hoping that climate change will be on the countdown next year with some really good progress.
Yeah, and just keep in mind, last time we were at, what did you say, 420 parts per whatever it was?
Yeah.
Last time we were there was no
Mastodons
ice
were around. Oh.
there was no ice on the caps last time we were there. That was megalodon, giant sharks.
Yeah.
And that number is 50% higher carbon in the atmosphere than before the Industrial Revolution of the 1900s. So we did this in 100 years, basically.
Mm-hmm. Mm-hmm.
We can undo it. We got the technology.
Just slow it down would be nice. I'll settle for slow it down.
Just tap the brakes, everyone. It's okay. It's all right.
I actually get worse gas mileage when you do that. So it just contributes.
Oh, shucks.
Unless, of course, you're using a Prius or a hybrid car where you're tapping the brakes, you're regenning your battery. So there you go.
Mm-hmm.
I want my regen brakes and better batteries. This is what we all need moving forward. Are we ready for moving forward down the countdown?
Yes. What's
One
next?
more. Number 10. 10.
Number 10.
10.
Number 10. Yeah, I know. Last week, 2 weeks ago, I was like, we're not going to talk about the National Ignition Facility and fusion finding, and it's not going to be on our countdown and blur. But okay, it's on the countdown as part of the category for big physics and the work that it's doing in coming into creating some really interesting findings and moving us forward as a society and hopefully promising us a better future, right? So National Ignition Facility, NIF, DOE's Lawrence Livermore National Laboratory Facility achieved ignition this year, and not just achieved ignition, but it by a factor of 10 improved its ability to create a hot plasma that was ignited, that had fusion. And this was above 2021's standards. So we're getting there. We're moving forward. Improvements on the lasers, improvements on the technology is going to lead us in the right direction. And the fact that in a year, there was a times 10 improvement in what they had achieved from last year, that is substantial. So good work. Keep working. We're all waiting for our fusion. I'm waiting for the Europeans, not just NIF, but the Europeans with their ITER and some of the other tokamaks and the stellarators and others to come online. I'm waiting for all y'all to make it possible. In the kind of boring but whatever big physics news, Large Hadron Collider, always one of our favorites, right? They're colliding particles constantly, huge amounts of data, massive experiments. It is kind of boring because once again this year the LHC has said, darn it, there's nothing special. Standard model still doing its thing. That was a very recent finding this last week.
So there's apparently some gray area on the edges of some experiments that they thought might mean there's a different, the standard model isn't complete. It's not correct. There needs to be an adjustment to make room for these. And then now, after some really intense experimentation at the LHC, everything we needed to know we learned from Einstein, and we should just stop. Physics is done.
Standard model.
That's good.
That's where we are. That's it. Yeah. But there are still other. The Gaia experiment had some data. There are other experiments looking at other things that are related to the Hubble constant, and others that will potentially be giving us better information related to some of the more big scale cosmological aspects of what we're looking at physically. And then, big physics, but on a small scale, we had one of Blair's favorite stories this year, the black hole in a lab, where researchers created a little teeny tiny black hole that started having the little hairs of releasing energy and information just like they should be, according to Hawking and other physicists' predictions.
So amazing and awesome in the actual meaning of that word.
And awesome.
And also terrifying.
But it's like a little baby black hole. It's not terrifying.
We don't understand them yet. Yeah. So what are you gonna do? It's scary. You're doing a thing you don't fully understand in a lab.
They understand it. It's fine. They tamed those black holes. That's fine.
Here's the analogy that you can use. A black hole works kind of like height. If it's really big, you have a reason to be afraid of being up so high. If, on the other hand, it's smaller than you have no reason to be afraid of that kind of height. Of falling down into or onto or whatever.
All right.
It's not
still makes me nervous, but I also am very much in favor of it. It's a very weird dichotomy. I am being torn apart from within because I'm like, that's so amazing and it's so cool.
Oh, kind of spaghettified?
Yes, spaghettified. You can say that.
Like you're being spaghettified.
Yeah, sure.
In addition to black holes, little tiny black holes, there was also this is the one that was debated as to the terminology and exactly how important it was. But I thought it was very interesting and wonderful advancement all the same because of the technology and the math working. And it's really, it's application as opposed to just theory. It's just showing that things are right, but the holographic wormholes. So using quantum computers to be able to create not a real wormhole. No, we don't have real wormholes, but these simulated holographic wormholes that have a lot of the properties in common with what we would expect a wormhole to have, and some interesting outcomes to the experiment that had not been expected related to how the information was transferred from one end of the wormhole to the other. And speaking of spaghettification, that there was a kind of tearing apart or entropic factor related to information going in, and then a more not logical but less chaotic factor for the information coming out. So it was torn apart and then put back together, kind of like an egg being unscrambled and scrambled, or scrambled and then unscrambled. And some aspects of these holographic wormholes. I've never tried it at home. No, I have not. Yes. Anyway, really interesting work. Amazing use of quantum computers to be able to advance our understanding of physics, which if we want to understand our universe, right, the theoretical physics being put into application, it's still simulation in a computer, but maybe that's what we are anyway. So it all comes back home in the end. We're all gonna
the only
learn
problem
little
I
bits
have
from
with
it.
that, is it seems like an evolving theory, because I'm old enough to remember that people thought, oh, what if we're all just on a telephone line and don't realize it? And before then, they were like, oh, what if we're all just in a telegraph machine? Whatever the newest technology
you remember back that far. Wow, you get older every week, Justin.
Yeah. Oh, what if all of reality is just part of a clay tablet that somebody's written something on? Oh, yeah, that's a theory. It's getting more convincing with the computer, but it's still just writing. It's all it is.
It's still just writing right on the wall, little shadows written on the wall. But I think we will move forward to our next topic. From these amazing, incredible physics applications and discoveries to number 9.
9. Microbiome.
Ooh, we love the microbiome. Why is it number 9, Justin?
This is one because there was a bunch of stories, as there kind of almost is, again, sort of like climate change and a lot of these things that keep showing up in abundance each year, or they just catch our attention, perhaps. But the one thing that I thought was interesting is there was multiple stories, one at the beginning of the year and a completely different one right towards the end of the year, and another one somewhere in between, that were linking energy levels to your microflora. The very recent one, where it's the mice and they looked at their genetics and they looked at their diet, they looked at every possible angle, and the only thing they could differentiate between the exercising vigorous mice and the lazy mice was that their microbiota was different. And it's kind of nice that that one looked at it through genome and everything else, because there was a couple earlier ones that had connected it to, oh, maybe this is affecting personality. Maybe it's affecting more outgoing personality or a more reserved, laid back personality, which is one way of looking at it. But if it's energy levels, if it's ability to keep running on the treadmill, then there's a probiotic that we should all take to get off the couch when we need to.
I love that.
Get off the couch. Take your bacteria. Let's do it.
Yeah.
I will also throw in my favorite microbiome story from this year, which was linking being able to identify people who'd suffered concussions based on their microbiome. So it's, essentially their microbiome shifted if they had chronic concussions.
That mind-brain connection is becoming much, much more clear with every passing year. There was another one too where this wasn't microbiome, but it was gut related. It was sensors in the gut that were reading different types of lipids, or one that looked for lipids and sugars, and one that just looked for lipids. And they tricked these mice, tricked, but they had this tasteless water they could drink that had a lot of lipids in it. And then they had another one that was really sweet that they liked. And they eventually all moved to the lipid one. And it turned out because the sensors in the gut were telling the brain, this is the good stuff. This is what I'm getting rewarded with. Yeah. So the taste for those lipids wasn't in the tongue. These mice were actually tasting the food and rating it from the gut. And the brain knew all along, but just never mentioned it to us.
Sometimes, though, like with artificial sweeteners, you might taste it sweet, but then it's your gut, which is one thing we determined this year, that there are different pathways within the vagus that go from the gut to the brain that are related to the microbial responses to these various sweeteners, real sugar, artificial sweetener, and which pathways get activated by metabolites. So sometimes it's like, oh, your mouth is like, oh, it's sweet. That's great. Let's start the sweet processes. And then your gut goes, no.
Still need more.
It's faking on me.
Yeah, you tricked the tongue. You didn't trick the gut. The gut still wants you to go out and get some Krispy Kreme donuts.
That's right. What else did microbes do? There was so much.
Those are the ones I brought to talk about tonight. But there
those
was
were
more.
your big ones. You're like, there were more.
Certainly more. Yeah.
There were a lot more. There was so many that at some point I think I stopped. I was like, I can't do another microbiome story this week.
I know there was a study on I think it was apes, where comparatively looking at their microbiome and ours, it looks like we lost half of our microbiome when we moved to the city.
Yeah.
That was a cool
there
one.
was city versus rural was part of that.
Yeah.
And there was also some involved in longevity too. Like people were living longer with different microbiomes. So we're gonna find out that all of the secrets to a long and healthy life.
Oh, for sure. Yeah.
Have to do with the gut.
And I still think it's crazy that medicine has not caught up and said, let's get your blood panel and your microbiome so that we have a baseline on you.
That's what we need.
Nobody's ever looked at my microbiome to see what's going on there.
No.
It's true.
So this was also the year that we interviewed Bryn Nelson about his book Flush, and we talked about something that I think Blair was very excited to hear, that people who are lactose intolerant, that when you eat yogurt that contains the lactobacillus species of bacteria, you can eat cheesy things. So if you're eating yogurt that contains things that eat lactose, your microbiome is being populated.
Have you tried
it?
No.
We must do these experiments.
It's too high
have
stakes.
To be too high stakes.
I'll get back to you. That'll be a resolution for 2023. I'll try it out.
Oh my goodness. Okay. All right. Well, moving on from the microbiome, we will jump to number 8.
8. AI, which stands for amazing impulse. No, artificial intelligence. Of course. So there was a lot of AI this year. This was the year for AI.
It really was.
It exploded. First of all, there were art bots. So if you were on social media, if that's a thing that you enjoy, you saw lots of Midjourney and other AI programs creating art. It's still happening. It's pretty wild. We also had AI outperforming humans at things like detecting whale songs and picking up information people missed in other studies, detecting exoplanets with gravitational lensing, being better at protein folding, coming up with algorithms, just a lot of things, but also ultimately proved that it could kill everyone.
Oh, jeez. What? No, it didn't.
Yeah. We basically fed it the information so that it could make a biochemical weapon if it wanted, and essentially did.
And it did. Sure.
Not good. So, there was also a study about the fact that AI has bad bedside manner. So there's more research that needs to be done about language choice with AI, which I'm not surprised about. If you see those AI generated scripts, it's very clear language is not the thing AI is great at yet. But yeah, AI was all over the place. And also I will say anecdotally, a lot of my Animal Corner studies conclusions were drawn because of AI systems. So they might have done research out in the field, collected data, come back to the lab, and then used AI to process that data to come up with an actual finding. So pretty game changing.
And I will add a jump on here. Patrick Pecoraro is jumping into our chat and saying many times, let's not confuse artificial intelligence with machine learning. And so I think actually you're right on there, Patrick. And what we are looking at in all of this stuff is machine learning. They're algorithms. They're given a big data set, and the algorithms then go about figuring things out. And so this is machine learning. This is not
technically.
technically it's machine learning. There's natural language learning processes. There's various aspects of how it's approached.
Well,
Yeah.
and I think it gets more foggy when
Yeah.
you look at things where the program makes strange jumps, like creating a biochemical weapon when given information on how to cure disease.
Well,
But-
yeah. So this was a company that only does machine learning algorithms to come up with helpful compounds that can be used in medicine. And they got invited to do a talk about how AI could be turned against us. Like, what's the evil side? What's the dark side of it? And they didn't really realize why they didn't know why they were being invited. So they go, well, let's see if we can take all of the buffers off and actually see if we can have our system, if our algorithms would tell us how to hurt somebody.
Yeah.
And it came up with all the known nerve agents that have been outlawed and banned from war. And it came up with a bunch of ones that we haven't discovered yet.
Yeah.
And it did it really quickly.
Yeah.
Very quickly. They move really fast. I mean, this year was the year that that AlphaFold and also another research organization's open access protein folding, where they were able to create very accurate protein conformations. The folding conformations for many, many proteins were removed, not just from proteins, but to other parts of RNA, DNA, other aspects of the cell and how they're put together. This year was the year that not only on the bad side, there was an antibiotic that was created by artificial intelligence. So it came up, our AI, machine learning, came up with a whole bunch of, really bad things for humanity very quickly, nerve agents to kill us, but it also came up with antibiotics that would potentially help save our lives. So there's the good side, there's the bad side. And this is I think where we have to be looking at this technology moving forward with all of our faculties as humans towards creativity, towards intelligence, towards what we expect from computers. The algorithms are just going to get smarter. They're going to collect more and more data. The more data they have, the better their predictions can be. Right. Yeah, maybe we will have a sentient computer by 2045 or 2060 or whenever it is that various people have predicted that we'll have super intelligent artificial intelligences. But at this point in time, we have some really cool machine learning algorithms that are doing some neat stuff, and they're giving us an opportunity to take a look down the road at where things are going to go. We have some neat
science faster too.
And do science faster.
Yeah.
Very, very good point. Yes. And also maybe know what to wear when you go to Soho.
Oh, yes. I didn't talk about that one.
No.
Oh, man. Yeah. And AI, machine learning system basically was fed a bunch of fashion information, was able to give suggestions on what to wear.
What should you wear if you're going to Paris? What should you wear if you're going to Soho?
I would not trust.
It's probably nothing that's in my closet anyway. So we will just keep on moving on. Have we talked machine learning, AI out? Talked it out. Okay. We're going to be creative on our own. We don't need AI. I actually tried to ask ChatGPT if it would predict the top 11 science discoveries of 2022 for me, and it said it couldn't because its information only went up to 2021, so it could not help me. Its learning library wouldn't help it make predictions. I was sad. I thought that would be kind of a fun way to start this show, but maybe next
check
year.
2021 against our 2021. See how accurate it was.
We'll check it. Number 7. Let's talk about brains and brain organoids. Oh, the neuron and brain research. Little tiny baby brains in dishes. doing so many very interesting things. This year, researchers got neurons in a dish that they created. They called it dish brain. That's what they do. They called it dish brain, and it plays Pong. They got a little tiny brain in a dish to play a very simple computer game, which in itself is very interesting. That means that little brain organoid, those little neurons, could take the input of the stimuli, correlate various aspects of what needed to be output, and then try to, I don't know, play the game, move the little thingy. What is it? I don't know, paddle? I think it just doesn't have a paddle. It didn't have hands. So it didn't have hands. It was just a brain. It was all nerves and electricity. But yeah, that one I thought was a very interesting application of what we've learned so far, and just kind of the basics of neural networks, of the needs of neurons, and the potential for networks of neurons to work together, wire together, fire together, and engage in an activity that is external to itself. It's like it's the basics of neurons, right? This is the basics of an organism needing to respond and work, create multiple cells that work together to respond to external stimuli in a way that is beneficial to the organism. What is the thing that it needs to do? What is it being programmed to do? And it was just dish brain playing Pong, but this is the basics. It's so great. And then researchers also this year took brain organoids and implanted them into rat brains. And it was just fine, and nothing weird happened. And I think that's just the interesting aspect of this particular study, is like, we're like, oh, it's going to be some weird Frankenstein monster, or something odd's going to happen. The neurons from the brain organoid aren't going to connect well, or they'll connect too well and the mouse will be too smart and
it's going to talk. No.
Right. It's, if we put human cells in a mouse brain, what is that going to give the mouse in terms of abilities? But what we saw is that these neurons, this brain organoid, it wasn't just neurons, but actually other supportive cells as well that go along with the neurons. And it was a hybrid brain. The neurons interfaced, everything worked well. And this could be the doorway that is needed and will be used in the future to be able to test therapies for human brain disorders. Because we can't test all the therapies in humans for human brain disorders, but we have lots of mouse models, but they're not the same as mouse models. But if we can put human brain organoids within mouse brains, then this could lead to a better testing arena. So,
but they're so small.
They're so small, but still, if you can target therapies and you can see if they impact behavior, if negatively or beneficially, then that's going to be something that will lead you in a direction that could lead to a new treatment, or away from something that will, you don't want to waste millions of dollars in research money on.
Yeah, I think that's inching towards the best model. Of course, the best model is going to be when we have a rat that has a completely human brain.
And it says, "Hey, Justin, how's it going?"
So how's this?
He'll be able to write that. He doesn't have vocal cords like ours, so it's just he'll have to write us a note.
Right. Press the keys on the keyboard. Yes. No thumbs, really. We'll see. It could get there, but yeah, brain organoids are moving apace. They are really, I don't know, they're really getting us to a place where we will be able to study a lot of the disorders of the brain without needing to slice open brains to get there. So that this is really good news for a lot of research that we want to do moving forward. All right. Are we ready for number 6?
Yeah, hit it.
Number 6.
I am not a number. I am a free man. 6. Number 6, ancient humans. there was a tremendous amount of stuff coming from, again, this year from ancient humans. We got a whole lot of ancient genomes, 8 to 10,000 years old, from South America, that kind of gave a picture of the populating of South America. Also added a couple mysteries, because there was one of those hints that there was Oceania, sort of a closely related genes to Aborigines, even. So, and that was on that northeast coast of South America, and nowhere else. So there's big puzzling, questioning things going on still about the populating of America, South America. We got older. The current modern humans, we now date back more than 30,000 years older than we were before. And I kind of like that story because it was a great lesson in how we do dating.
Yeah.
Because we had tracked that there's this layer of ash from a volcanic ash, and so it came from the volcano over there, right? And so everything we could figure out when that thing had erupted, because it's everywhere. And so we've got this idea it's less than 200,000 years, because the bones are right down there. Well, turned out they've now gotten to the point where they can analyze that volcanic ash and tell which volcano it actually came from. And it wasn't the one that was nearby. It was one much further away that had a much bigger eruption a lot longer, 30,000 years earlier. So now they realize, okay, so that also pushes the date of everything they've dated based off of that, including some current modern humans from back in the day. And it's sort of interesting too, because then, when we start pushing that date back to more than 200,000 years, there's outlier data that no longer is outlier data elsewhere. There's the outlier. So we know the Denisovan cave, right?
Yeah.
So that's where we got the little finger bone of the first Denisovan. Well, there's also Neanderthal DNA that we've gotten from that cave. And that Neanderthal DNA had a big puzzle, because it looked like there was some current modern human admixture to some of it. The problem was it dated to 200,000 years ago, before current modern humans existed, let alone left Africa. So now, but now that we have, then the date got pushed in the one, and now the other one that was this outlier isn't an outlier anymore. Now there's 30,000 years for that one same individual to have gone wandering up north to Siberia. It's a
Which 30,000 years, that's a long time.
Plenty of time.
That's plenty of time.
We also had some.
How do you even live that long?
We had some of the earliest cooking and fishing that was found in Israel, in a site. There was, I think, the oldest current modern human remains to be found in Spain. Was so everything. It's always the bigger story when it pushes back the date. We also have to remember we're also collecting all sorts of ancient human data along the way, filling in culture, diet, genomics, spread of language and humanity and art. So it's always a good year for ancient humans. It has been for a while.
Always a good year now that we're looking back at them. I mean, for a long time, it was nothing. And I feel like with the modern technologies that are enabling us to look more deeply at some of these sites and the fossil remains, and like you mentioned, the dating technologies, the various ways we're looking at DNA evidence, RNA, lots of stuff. We're going back further with more resolution than we have before. And in the last decade, we're talking about whole new arms. We're talking about a tree, the braided stream, and all these things.
Yeah, so it's very braided stream too, because we're also now talking, there's tremendous amounts of Homo erectus-like, Neanderthal, Denisovan-like, a whole array of ancient humans being discovered in China. And how do they fit in? So even within the braided stream, one of the things we have to start keeping in mind is something like Homo erectus that was around for much, much longer than humans are, diversified. They went everywhere, and they diversified everywhere. So the Homo erectus type ancient humans are different in Western China than they are down in Indonesia, than they are down in the Levant or down in Africa or up in Europe. They're different everywhere. And so that the whole idea of pegging humans as a one, that's been obliterated in just the last few years.
It's so recent, and I love that we're talking about it so much. And yeah, I'm glad you bring all these stories to the show with so much insight. Oh my goodness. All right, well, we have talked from number 11 to number 6, and it is time for us to take a quick break. This is This Week in Science. Thank you so much for joining us for this episode, our top 11 of 2022. We are halfway through the list, and it's time for us to continue down to number 1. So we will jump on back right now after I remind you that if you want to head over to twis.org and get yourself a TWIS Blair's Animal Corner calendar, it is available now. You can head over to twis.org, click on the calendar links. You can purchase a calendar through Zazzle physically, or you can also purchase a PDF download that you can print yourself or take the images and put them on your computer and all that kind of fun stuff. The PDF download has some pretty fun science holidays included. You can do both also. Get them both. All right, this show, we already hit Patrick. This show, we're going to 11. That's right. We're going to number 1. We are going to start at number 5 right now.
Number 5.
5 is all about eDNA, which stands for electronic DNA. You know, you open up your computer, it says,
that's
you
No.
got
it.
mail. You
No.
got DNA.
Nope.
You check it. It's an
Nope.
electronic DNA. No?
Nope.
Oh, sorry.
Nope.
It's environmental DNA, of course. I'm just fibbing with you. Anyway, there were lots of good stories about eDNA this year. The one that I usually run over that we've talked about for years now is in water, just like what kind of fish is around. And you can pull out the water and you can check the DNA just floating in the water. And because fish pee and shed skin and do all sorts of stuff in the water, it's just in there, right? But things went a little crazier this year. A couple of my favorite environmental DNA stories is that if you just take an air sample from a zoo, you can get most of the animals in the area. It's very aerosolized. But my for sure my favorite eDNA story from this year is that most tea contains bug DNA.
Yes.
Not necessarily bugs, although probably a little bit of bugs. It just, there could be environmental DNA because they chomped on the leaf and they left some saliva behind, or they frassed on the leaf. I'll say frass because it's less gross, right? It's bug poop. And then, or just, you know, exoskeleton flakes or whatever. But so essentially, researchers can take environmental DNA from tea and draw conclusions about where the tea came from, or if they know where the tea came from, what bugs are in the area, which is very cool. And also,
you could probably also have information about how insecticides are working in certain areas and how that's impacting the crop and, you know, what's going on. There's a lot that can be done with eDNA.
Where tea is being grown, it's being dried, typically outdoors. You know, so before you drink any tea, you should really boil it in water to sanitize it.
Oh, wait a second, Justin. That's what we do anyway. Also, I don't know if this counts as eDNA, but I threw it in here anyway. There was a whole study about using leeches to understand the biodiversity that the leech came from, because they draw blood from a bunch of different animals, and so they can actually pull DNA from the blood, from the guts of the leech, to figure out what animals are in the area. So you could consider
Yeah,
that environmental
I like
DNA,
it.
I think, because it's not you're not testing the animal, you are testing the
Environment.
stomach of another animal that didn't actually eat that animal completely. So it's just kind of like, what's the cocktail they got rolling around in the leech tummy? And I know, Justin, you were excited to talk about this too. Did you have any to add?
Just that we've conservatively, at least, I think, gone back now 2 million years and
Yep.
collected DNA. Last record was 1 million years. It was from mammoth bone found in Siberia, found in permafrost, I assume. And we've managed to extract some DNA from that ancient beast and reconstruct it a bit. Now with environmental DNA, we've at least doubled that. And we didn't get one thing. We got a mastodon. We got crabs. We got reindeer. We got hundreds and hundreds of plants. We have an entire biome that we've managed to rebuild.
And this was from an ice core or what?
So it's from a soil core.
Soil core.
So there's a fjord up there in the north part of Greenland that had gotten, the tide goes in and out, drops down sediment, and it did that over a couple million years. And then the ice came down on, got covered in ice, and then it was stuck under that frost. So it was super cold, no oxygen. But the real thing, the thing they think that actually managed to keep this DNA preserved is the amount of quartz in the soil. So quartz has a charge, DNA has a charge, and by the DNA bonding to the surface of the quartz, it preserved it chemically. So it didn't break down like it normally would. And so the story's kind of fun because they've had this soil core for I think a decade or two, almost 2 decades. And every time they had a new technique, they would try it out in the core and get nothing. And then, time would go by and they've got some new techniques and they test it out on this core and get nothing. And then, and it went on, I think 4, 5, 6 times. And then finally, with the latest round of innovation and really brainy thinking, they managed to do the extraction. And so there's this wonderful glimpse, the furthest back glimpse we've really gotten into animals and plants. And really, I think also the amazing part of this story isn't actually the collection of it in one of the more hostile environments on the earth. It's not even the information that they ended up with, as amazing as that is. It's the fact that they were able to reconstruct so many genomes, starting with mere fragments. And that's one of those, go into the power of machine learning or algorithms being able to assist. That is not something you can do by hand. It took people a decade and $1 billion to piece together the human genome that way.
I was just thinking about that, sitting in high school biology and watching this video about how they're so close. They're almost done. They've been at it so long.
Yeah.
I think that news came out again this year, which they were like, oh, we really finally finished it this year.
Good for
really
you,
got a little bit more accurate. Yeah.
Well, I mean, the truth is you can do that with pretty darn good accuracy in 48 hours, an entire human genome. I think with the Oxford nanopore, it might even be quicker than 48 hours. But it's sequencing a gene itself is no longer the biggest obstacle. Right. But in this scenario, when all you have are little tiny chipped, cut up fragments from across a whole biome that have all donated something to this mix.
Yeah.
To be able to take that and reconstruct goes to show all of that's why we went and sequenced the genome of a crab or of a reindeer or of all these other creatures that we may not plan on doing a whole lot of experimentation on, but now we can see when it belongs to that family and when it doesn't, when it belongs to something else, when it belongs to a particular type of plant. Little bits of that code, when they match up and to nothing else, then we know we've got something that's a match there. But that whole that whole process was just really fascinating to me.
Ancient eDNA, new eDNA, current air DNA, blood DNA, tDNA, and ancient. Now let's move on to number 4. Four. The cause of MS? Do we know? Yes,
we?
well, yes, it was reported this year that scientists have linked the Epstein-Barr virus with causing multiple sclerosis. Now, this isn't an absolute 100% knock it out of the park finding. And of course, this is science. So there are many individuals who debate this. And of course, this autoimmune disease, multiple sclerosis, may have other causes related to different viruses. But in this particular study, researchers, after a 2-decade study, found that Epstein-Barr viral infection is the leading cause, not just correlated necessarily, but actually causing the virus. We know Epstein-Barr virus causes mononucleosis. If somebody can avoid it until adolescence or adulthood, you're more likely to get the mononucleosis. A lot of kids get it. And some people are genetically predisposed to have certain reactions. And it depends on environment, depends on all sorts of stuff that are going on. But
we've been informed of that, like through this latest pandemic. I think everybody's aware.
Everything
we can all get the same virus
and have different outcomes.
And have very different reactions and outcomes.
Yeah. But it's very fascinating. It's like being able to years ago be able to start vaccinating for HPV and and suddenly have a reduction in a number of different cancers. Not just one cancer, but a number of different cancers, not just in women, but also in men. Things that we didn't know were linked, but that were virally being caused because of interactions between viruses and our immune system, viruses and bacteria and our immune system. We are learning so much. And like you're mentioning, Justin, COVID-19 has been in the background of everything this year, the foreground for many of us still. It is the ongoing pandemic that has never ended, but it has also allowed us to dig even deeper into viruses as the causes of disease, looking at SARS-CoV-2 as a cause of long COVID, for instance. We're looking at all sorts of things in a different light. Chronic, Chronic, when you're tired.
Fatigue?
Fatigue, yeah.
Thank you. Chronic fatigue syndrome and many others, which had been linked to, but people have been fighting, really, really working really hard to say there are viruses involved and we don't know exactly how, and there's something happening here. Now there's a little bit more going on. So I think that it's not just that we're seeing this year this particular study that really targeted Epstein-Barr and found it to be incredibly highly linked to the cause of multiple sclerosis. It's that we're looking at viruses across the board in a new way. And if we continue to do that, it's going to benefit us all as a society. End of story. Moving on to number 3.
Ooh, three is all about one of my favorite things to talk about, regenerative medicine.
Oh, is it now?
Yes, because we have found all sorts of ways that I may work to live forever this year.
That's right.
Some of them won't affect me directly, like the ability to make synthetic embryos, although that was mind-boggling. Basically make an embryo with a beating heart without an egg or a sperm. So that happened. Also, a dead pig was made, basically its organs were kind of reinvigorated after it was dead. So then there's this whole question about what is dead, and also, yikes. But
this is also why we have to give
What
this
is
why we need
death
that
anyway?
brain organoids
Yes.
to develop, and then you give the pig a human brain, then you kill it and bring it back so you can talk to it after, and it can tell you
There you go.
what the other side is like.
Perfect. Yeah. So essentially, this is not the horror story it sounds like, but it does mean that there are lots of ways to keep organs healthy longer, which is really what this is about. Speaking of that, there was a human that received a pig heart transplant that went better than expected. They did not survive the year, but they survived longer than their outlook was prior to the transplant. So it was a net gain of time, and it went better than anticipated, but still a lot to do there. And then also we had lots of animals regrowing things. Axolotls, as always, kind of the poster child for regeneration. They regrow parts of their brains after injuries. There were studies looking at how we can kind of harness that ourselves. And then also there's a study where
the hydra can regenerate its whole head.
Right.
You can take the head off and it'll just I'll just make a new one.
Yeah. Too bad they're not real. Anyway.
No. There's something that is real that's called a hydra.
Called a hydra, but it's related to like jellyfish. It's not.
Yes.
It doesn't have a
really
head.
small.
It does have a head.
It has a head.
Anyway,
Sure it does.
and then also, don't try to animal corner the animal corner. All right. Anyway, also there's a study about frog legs where they were able to stimulate regrowth of some amputated legs in a frog, which is so cool. Yeah, it sounds like there's lots of good stuff on the way. We'll be able to keep organs alive longer. We're further on the path to regenerating limbs and brain cells. Brain cells are really the thing, man. Like, obviously, it would be great to be able to regrow a finger or an arm or a leg, but regrowing brain cells, that's the top of the list, because that's like, brain deterioration as you age. Wouldn't it be great if you could just regrow parts of your brain?
Yeah, you know what? And it could be a good therapy, because I think there's people out there who want to get rid of memories.
Yeah. Eternal Sunshine style. I get it.
Well,
yeah.
I don't necessarily mean it like that. But PTSD, and really, I guess that's an amygdala, frontal cortex connection issue too. But like if somebody was like, hey, your brain's starting to deteriorate there, Justin. If we get rid of a bunch of your memories, we can put in some new brain and regenerate it, and you'll have a very well functioning brain, but you'll have to lose a bunch of your memories. That would be tough.
Do you want to be a new person? Do you want to potential? Yeah.
Yeah.
Just grow more on top. Just a little more on the top for me.
It would very much depend on where that. It's you have to learn to rewalk or retalk. That might be something I'd be willing to take on, more so than not remembering. Of course,
I just want to be brainchild from the tick. That's all I want.
That's right. Just chair face. Carve your name into the moon. There's so many cool things going. Regenerative synthetic biology, regenerative stuff is so neat. Just being able to take things that are getting older and regenerate them. Can we someday have new limbs? Can we fix our brains? Can we get rid of the organ transplantation problems that we have? Can we actually have organs for people? Like, what can we do with people get close to death? Can we help them?
Myelin sheaths. Can we regrow that? Can we regrow bone when there's osteoporosis going on? This would all be amazing.
Ooh, yes.
Can't wait.
We're getting there. So many good things.
See you on my 300th birthday on TWIS episode 10,000.
Can't wait to hear the stories that we've got then. Moving to number 2.
Two.
Wow, we're already at number 2. This was a big year for curing cancer and HIV.
Seriously.
There was a kind of earlier on in the year, there was a woman who was completely cured of HIV with an umbilical cord treatment, a stem cell type therapy. And, you know, when we hear about these things, you got to say, oh, gosh, well, maybe there's, well, and then there was another story about the fourth person who was cured of HIV with a different technique. We had a couple of different cancer treatments, one in mice, one in rats. One was an embedded drug system that was working basically on its own, then taking down tumors. We had a sound therapy one where they could actually go in with this high power concentrated and disrupt and break up tumors without doing surgery, without cutting into the animal at all. And then, of course, we've had a number of different. There was one not a couple of weeks ago where they had this drug combination that was putting leukemia patients into undetectable remission. They couldn't detect the disease in like 85% of the patients.
And that kind of thing is amazing because that's in people. That's not mice. It's not rats, even though the mouse and rat stuff is like getting us forward. But this is like the first year that I think we've had multiple findings of remission or no cancer found in humans with different studies.
Yeah, we had some success early on with the CAR T therapies.
Yeah,
those were making it disappear and almost giving an immunity to certain types of cancer. But they're very expensive. But they were also initially had this couple of % chance of going completely haywire and killing the patient. So you want a cure that doesn't have a chance of killing you. That's always preferable. And that seems to be what we're getting. You know, putting HIV into complete remission, putting cancers into complete remission. And there's another one in here that I don't remember this one. This was the colon cancer. I don't remember that one. But that
rectal cancer. Yeah, four patients all went into remission. Wow. From immunotherapy treatment. Yeah, so 4 for 4. It's a small sample size, but still, again, in humans.
You take it. Especially if you're one of those 4.
Yes.
You're going to be appreciative.
If you're one of those 4 or someone who knows one of those 4, you are thrilled. So
we and these are phased, you know, once you're into human trials like these HIV and a couple of these cancer ones we've talked about, we're in 2, heading into 3, maybe at 3, heading into a treatment that you can get from your doctor. You're getting this research to that point now where there's going to be certain cancers that we take off of the table for death. That we take off. If you get this, you won't have to live with it, and it's not going to be the thing that kills you. And that's huge.
And so it's 2022.
Yeah.
We started doing this show back a long time ago. KTBS 90.3 FM, Davis, college radio. 22 years ago that we started, really. Maybe a little bit more than that, but I'm not counting. Who's counting?
22 is enough.
22 is enough. But so many shows we reported on possibilities for potential cures for cancer. We reported on gold nano dots, gold nanoparticles that were being used to be embedded into tumors that could then be used for ultrasound to heat tumors from inside, using sound to vibrate the gold particles. It was 20 years ago, and that was like early research into this stuff. And now we're seeing very specific ultrasound being used, hyper-focused ultrasound being used to disrupt tumors. We are seeing humans having what I'm now seeing is called NED, no evidence of disease. We've got to keep up. It's not remission anymore. It's no evidence of disease. Thank you, Shubru. We are seeing this in humans, in people, based on research that's been ongoing for 2 decades. And, in the early 2000s, it was, oh yeah, cure for cancer. Every interview we had.
Yeah.
5 or 10 years. 5 or 10 years, we'll have a cure for cancer. Nobody was really talking about what is cancer?
Yeah.
It's a bunch of different diseases.
Which cancer?
There's a
Which
lot, yeah.
cancer? What are you talking about?
spectrum of
Yeah, cured in which stage and all this. Yeah, absolutely. Mhm.
And so I think that our conversations have become more nuanced. I think that the way we're looking at it as people is a lot more nuanced. The scientists working on it obviously were in deep in their particular niche of what they were studying. But I think that what we've seen over the last 2 decades, like, I don't know, this is amazing. This year was great. Cancer, HIV. I mean, we grew up during the HIV pandemic, and I'm so excited about all this and where it's going. No cures yet, but we're there.
Well, we're getting there. I mean, I think we
close.
have cures now.
We're like
There's
right
Especially-
options.
Really on
Yeah.
the brink of so many things. It's amazing. Yes. Okay.
But
I'm excited.
and this is one of those things too. Like, this is the last word on that. There's 30 million people who actively have HIV currently on the planet. So it's
Yeah.
30 million people who need this research to keep going.
Yep. And there's like 3 who have been cured so far, but
Yeah.
yeah, it's a start.
5.
5. Okay.
Oh.
We're up
Hey, just
Get
to
the
those
numbers
two
right.
people in their
For
entire
those
extended
2
family,
people and the people that know those 2 people, it's a big
It's a big
difference.
deal.
You're right. You're right.
Are we ready for number 1? Is it
Let's
time?
hear number 1.
Number 1. Did everyone guess? Number 1. Did everyone guess what this was going to be? Do you know what this is?
This was the no-brainer. This was the one. This is one year where we didn't even argue about it.
No, not at
No.
all.
And we have debated on previous years, like what's going to go where and which one can be and who's it, what's it, which it. It's NASA. NASA takes home the number 1 spot this year. NASA James Webb Space Telescope.
Mhm.
We've been waiting for that one for over 15 years. That
Mhm.
one is such a long time in the coming. And, over the last year or so, debates about its name put to the side. Let's just talk about the science. Let's
Mhm.
talk about the fact that this multi-billion-dollar space telescope, the successor and cohabiter of space with Hubble at this point in time, it unfurled. It did all the things it was supposed to
Did the
do. It had
thing.
so many ways it was going to go wrong. Webb won. Webb won the year. Webb started bringing us new images of things in
Beautiful.
ways that we just didn't expect. And it also brought, of course, new controversies within the world of astrophysics and cosmology. And what does this mean? And what does that mean? And what does its data mean? And can we look deeper? So there is so much more that's going to be coming. Webb was amazing. We also actually returned to the moon, kind of. We got Artemis launched, which I was convinced it wasn't going to happen. Artemis launched. It went, the Orion mission went around the moon, and it came back safely.
Okay.
Everything was
So-
good.
Yeah, the only problem with that story
did
is, it's like sort of getting really excited about walking to the corner store when for the last decade we've been launching all kinds of things to Mars, much
Oh,
further away. We're landing, we got robots running around on Mars, and we're like, hey, we just walked to the corner of the moon over there and back. It's not as it doesn't hold. It didn't get me. I'm like kind of surprised that it was even such a big story. I mean, I get it. This is for future human exploration, and it's the
Yes.
test run. I
Exactly.
get that. That's important.
This is the first step. It's like the phase 1, phase 2 trial, right? You get the thing launched, you show that it works, and then you go, okay, now we can put people on it. And then we're going to take people to the moon, and we'll land on the moon. We'll have a new rover on the moon. We'll start doing science on the moon. Oh, maybe we'll build a Maybe we will have a place where we will let people live on the moon. Maybe we will have a spaceport on the moon. Maybe we will use it as a launch pad to the rest of the solar system. Like, this is the beginning of our next steps
It'll
back
be
out
a
into space
billionaire
as
resort.
people.
It'll be a billionaire's resort planet.
Probably.
in
I
10
don't
years.
want to talk about that right now.
And then
Anyway,
it'll affect the tides because we're going to put too much mass on the moon.
no, it's not. We take enough off the Earth already. We're losing water. There's all sorts of issues going on. Okay, anyway. The big thing beyond that, at the end of the year, that NASA knocked out of the park. I mean, it's seriously like 18 holes of golf in the solar system. And then it's like, boo, we're going to do a hole in one. And the golf ball is not just going to do a hole in one, but it's also going to shoot down to the core of the Earth and spew out the other side. And anyway, the DART mission to push an asteroid. We did it. We shoved Dimorphos. We shoved a little moonlet of an asteroid. And in our shoving, we shoved it so hard that we could see just how much we pushed. There was a multi-thousand kilometer tail off of Dimorphos after the event. And the idea is very, very positive for our opportunities in the future of being able to push threatening asteroids.
Yeah.
To act a little like I can protect myself. We could do something
this the
here.
year the movie Don't Look Up came out? I
This
do
is
believe
the
it
year.
is. No,
Yes.
this is. I know NASA plans
Yeah.
things way in advance, but it does feel like very interesting timing. That movie came out, we were all like, "Oh no!" And then, "Oh, don't worry about it. We got a DART."
Oh no, we're working on this. We're
Yeah.
actually working on it.
Perfect timing.
Yeah, so it was just a little moonlet, but it's a little moonlet with mass. And what we will learn from what our shove did to its trajectory around Didymus, its asteroid, and how its orbit changes, and there's a lot of data still to be reported on, but it's looking very promising. I mean,
And
it was really, really a great effort.
And I shouldn't be talking about this on the show like this because there's a very good chance I'm just misremembering this or misheard this. But I think that tail that we're seeing from it, we must have hit that hard or something, or things just break up in space. Because I heard there was like millions of tons of debris that got schlepped off of it, that came off of
Tons. Yeah, that was the massive tail. Yeah, tons of debris. Yeah. We hit it hard.
Yeah. That wasn't just a little soft nudge. Like,
no, it was a
rocket comes up, lands, and then
get out of my solar system.
No, it was ramming speed right there. We slammed into that thing.
Ramming speed. Oh, humans, we really know how to throw our weight around in this little solar system of ours. Yeah, it is.
Can we fix it with a splosion? Is my question.
Well, we can fix it with a rocket. Yeah, it's a little shove. Yeah. So James Webb, DART, all the work on Mars, all of the effort with Artemis and the Orion mission, NASA has really been knocking it out of the park again with some amazing efforts, discoveries. And this is, I think, the exciting thing and why it's really number one is that what NASA is doing is the place where science and engineering meet, where you have the best engineering making the best science possible. And because Webb is where it is, we are going to be learning so much more about our universe. Because DART was so successful, we are going to be potentially more protected in the future. Because Artemis was successful, maybe humans will be back on the moon sooner rather than later. So I see a lot of hope here.
Yeah, with that James Webb too. The thing that I guess I I didn't realize was going to be so impactful was its ability to look at exoplanets or to look at really distant planets and get information out. I knew that it was going to get some deep looks, some galactic looks, that it might be finding exoplanets. But being able, the kind of data it's getting from exoplanets is telling us about atmospheres on them. I mean, that's all in completely new level of detail that we're getting for what other planets are going to look like. And then, of course, it means that's an accelerated search for
Life. Are we alone? Are we not?
No way.
More water worlds? Yeah. We're going to be able to. And Blair, like you said, with a story that we did not cover on this top 11 countdown, one that was your favorite was the panspermia evidence, where now we have shown that RNA and DNA are spontaneously formed on meteorites.
That's
And
right.
we've found them all over the place, found RNA and DNA all over the place. And so it's stuff like Webb and the way Webb looks at signatures, chemical signatures in atmospheres and around stars. We'll be able to see these signatures much more easily.
I think isn't it just RNA? I don't think it's DNA.
Oh, and DNA.
It was both, yeah.
Both.
Both.
RNA and DNA. Yes.
So are we sending it out there? Is it coming from out there to us? Is that where we came from? Can't wait to find out. I'm so excited.
Must watch TWIS next year.
I think actually the more exciting thing is that there's those chemical components, meaning physics being the same everywhere in the universe, standard model applying everywhere in the universe,
and if chemistry,
the chemistry is not going to be
chemistry applying. If it all applies, then
it's everywhere.
Then
it can be any planet that has the right conditions or a range of conditions that could work, will work, and probably have, because it happens so. Our one example that we've studied up close is this planet, and it happens so quickly after the forming of this planet.
Mm-hmm.
So
that we are
quickly.
either the exception
or the rule.
And if we're the rule, there's a lot of us out there.
And if we're the exception, there's still a lot of us. Just
I know, because there's enough planets.
Because there's a lot of planets.
Plenty of room for exceptions.
So speaking of things that are going to be interesting moving forward, okay, we've finished number 1. We're going to be moving into some other fun science stories that we want to talk about just beyond this. But we've basically finished our countdown here. But in big physics kind of stuff, we are going to be looking at LIGO and its co-telescope constituents around the world. They're going to be not just looking at black holes, but because black holes, when they merge, they create a rippling in the fabric of space-time. LIGO is going to be used to test the hypothesis that if there are other life forms out there with greater technologies that are potentially using big warp drives and things like that to move through space, that if they're there, here's the hypothesis, right? If they are there, then they would likely be causing a signature on space-time. And
Catch
so they're
warp signatures. Star Trek is real.
Yes, they're looking for warp signature. So instead of triangulating on the ringing of a bell in one particular place in space-time, they will be looking to see if there are moving signatures across space-time, which would be indicative of something like a warp drive or other very large influence on space-time.
I can't wait. This is amazing.
We're using our technology to be investigating these so sci-fi things. I mean, okay, we're looking into the future now. But anyway,
I know. Okay, never mind.
But this is This Week in Science, and we finished our top 11 countdown, and we are thankful that you have joined us for this show so far. Remember, if you head to TWIS.org, you can support us on Patreon. You can also click on the Blair's Animal Corner calendar links, and you can buy a physical calendar, Or you can buy a print it yourself PDF calendar. Beautiful, beautiful Lego animals and backgrounds and such great stuff. Head over to TWIS.org, get yourself a calendar for 2023 and support TWIS. You can also support us on Patreon. We appreciate all of your support because we are listener supported. So thank you for all of your support. We can't do it without you. We're going to come back because you always want to know about those other stories, right? What are some of the stories from the last year that we were like, oh, I love that story, but it's not quite on the list? What was 13? What was 14? What was whatever? Blair, tell us what were your favorites, your MVPs from 2023 in the Animal Corner.
Oh, well, my MVP in general for the Animal Corner this year is spiders. Now, I know we talk about spiders a lot.
And how much you don't like them, but you like them.
In general. I both do not like them in my personal space, particularly near my face, but I also love them from afar and love spider science. It's a very strange relationship I have in my brain. Anyway, they did so many things this year. We found out that spiders sleep and they'll nap and they'll snooze. We found out that spiders catapult away from the males will catapult away from females to avoid getting eaten, which was amazing. We found out that they can hear sounds just in the open air through their webs. Their webs will resonate to be able to read them, almost like guitar strings. We found out they can curl leaves to form their own little homes or hats. So it's kind of like tool use. And the one that is particularly terrifying is that we've talked about spiders hunting in groups before as like, oh, did you know some spiders hunt in groups? Turns out a lot of spiders hunt in groups, enough that there are different strategies in the spider canon of how to hunt in groups, and that they all kind of have these different strategies depending on where they live and the type of things that they eat and all these kinds of things. So spiders all over the place. There were even more. There was one about making an artificially created spider silk that could be used as a nerve sheath for healing nerves and in your body. There was another one about spiders dancing and how the quality of their dancing impacts their mating success, but also their kind of energy level impacts their dance. It was a whole crazy thing. Anyway, search spider on TWIS.org, browse through these. It's all amazing. The newly trending topic in Blair's Animal Corner that started this year?
Yes.
Clitorises. We started and ended the year talking about them. I did. In January, we found out that dolphins have clitorises and that it seems like there is an element of sexual pleasure for female dolphins. Go fig. Then we had basically the exact same story for snakes in December. Was that last week?
It was like last week, yeah.
So I think, and in both of them, I kind of lamented how this isn't studied. Male pleasure in copulation is studied because it's all about spreading the seed, and this is the whole kind of narrative, right? And then so the female side of things hasn't really been looked at, but then like, why did these structures exist, and why would they only exist in humans and not in anyone else? And so the fact that they were found in two completely different groups of animals, in mammals and reptiles, and the fact that both of them showed similar kind of indication of potential for sexual pleasure, and that there would be an evolutionary benefit to that. You're going to see more of this, and I will report on it when it happens. I guarantee you.
Blair, are you saying that we will see more clitorises?
Yes, we will.
TWIS. Okay.
Yeah,
good.
We certainly
Good
can. And those high school teachers out there that play our show, this is biology. This is real science. I'm using the scientific words. This is important to learn.
Yeah.
It is.
Yeah, no, because my first question is this convergent? Or is this...
Right. And it seems like
Are we
a
talking
copulatory
dinosaurs?
organ. A copulatory organ we do not think is convergent. We think that has an evolutionary ancestor that kind of way in common way back there. And if also recognizing clitoris is in terms of embryonic development the same structure as a penis,
Yes.
means it is likely to have the same origin. So this is kind of one of those things that's like, yeah, that would certainly make sense, but nobody studied it because for some reason female pleasure and sex is taboo and it's not talked about. And it's like, is it even there, even in humans? And so it's, you know, it's a whole, I can't wait for this to open up a little more. And I want to learn all about it.
This hasn't been in doubt if it was there in humans.
I mean, not by scientists.
I think you're.
Yeah.
But you're talking about something in the air. It's just, I don't even know if it's taboo to talk about the G spot. That's what I think. That's the one that people are always like, is that a real thing or not?
Right.
No, it's
But
it's both.
not the-
It's both.
It's both.
No,
But it's both.
That's the
Yeah.
physical structure. That's
But this all stems from a lack of study into female anatomy, into like even the female psyche and various
Yeah.
aspects of female reproduction because of who the scientists are, who's been allowed to play, and the questions that have been asked. So this is
Absolutely, yeah. And it's all, you know,
changing.
if I may say the flamboyant thing, it's based in misogyny, people. It's based in this idea that like women are vessels to grow humans, and that's the deal, right? And so like you need to divest that from the situation and recognize that there's the potential for evolutionary benefits to pleasure on both sides. It's not just a vessel. The egg is also selfish and needs to be tended to. So
Ooh, those are bold words there, Blair. The egg is selfish.
Yeah,
What?
it is. It's a lot
The
of
selfish
a lot of
egg.
resources. The animals with eggs are born with all the eggs. That's it. You got your eggs. It's got to be selfish. Anyway, so clitorises. You'll hear more about that hopefully in 2023. Fingers, toes, and legs crossed. Anyway, and the last thing I wanted to mention was unhinged robots. This was a very strange year for weird use of robotics. And I'm using robotics very loosely, so don't yell at me in the chat room. But I am including one thing in this kind of conversation, which is necrobotics, which
That
is
was
the
such a
use
good story.
of dead spiders and injecting them with air to open up their legs and then use them to slowly, gently close and pick things up that are very fragile. Will we need to use this? Doubtful. However, proof of concept maintained. Also, there was a robotic tentacle made that looks like spaghetti that you could pick up, again, fragile things with or things that are weirdly shaped. It's bizarre. But the tentacle robots, oh yeah, Kiki showing the necrobotics right now of the spiders. They were able to put air, inject air to mess with the hydraulics of the legs. They could pick stuff up. Just truly deranged.
I really want that in like that next
totally awesome.
kid grabber toy at the local arcade.
Do you need the dead spider for that, or can you recreate the hydraulics that are spider legs? I think you
Who
can.
knows? Who knows?
It's anyway.
Yeah, but it's funner to use a spider.
It is.
Yeah. So then there was the crazy spaghetti tentacles that were
Yes.
robots, also for picking things up. Lots of
Yep.
pressure on picking things up this year. And then the last thing, the thing Justin actually wanted to be the #1 story of the year.
This is the only thing
Yeah.
I would have put ahead of NASA because I think it is. You know, when NASA is like, we went around the moon, but we're gonna put a man on the moon next time around. This is a version of going on the moon. This is a feat as big as landing
And of
a man
course,
on the moon.
Justin is talking about the goldfish that could drive a car.
Yeah.
So not a normal car. It was a tank with wheels. And so they taught this goldfish how to, with the air, where they swam in the tank, to steer this little tank on wheels, this little goldfish car, this auto
This
mode
fish
tank.
is driving the
Fishbot.
tank. There's nobody with a
Yeah.
remote control.
Yeah,
The
he's
fish
driving it.
is steering this. Yeah, forget the moon rover. you got this fish rover now. This to me is
Yeah.
the biggest, really is the biggest story of the year.
And Fada's saying he thinks it's Ig Nobel Prize worthy, and I would say it's not, because it's actually a more serious thing. It's a proof of concept that is it's silly on the surface, but I think is really cool in a lot of layers. So you're proving that a goldfish can figure this out, first of all. Second of all, that it can indicate preference of where it wants to go and adjust. But then third of all, that they were able to invent this thing that could interface with a fish.
So yeah, it is possible to make technology so user-friendly, literally a fish could use it.
Yeah.
So no excuses for your complicated user interface.
And I love that it
sync and pair and do all these things. No, you don't need to do any of that. If the fish can drive a car, then
So
all
can
the rest
you.
of this,
Yeah.
the self-driving car should be here yesterday. Well, maybe it was.
Well, the self-driving fish car would be a remote control that the humans were driving, so that's not quite right. You want like,
Yeah, you
I don't
still
know if
need
you've
to-
seen
yeah.
Star Trek Discovery, but they have these particles that you just kind of move your hands around and it steers the spaceship. That's really what you're talking about, because that's what the goldfish is doing. It's just saying, I want to go that way.
Yeah, basically.
It goes
yeah.
that way. Yeah. So anyway. So yeah, the
That's
fish bot
that
car.
is my favorite story of the year.
Yeah. It's a breakthrough, I think. It
like
seems
all year
silly on the
long.
surface, but it's scientifically it's pretty cool.
Mm-hmm.
Who else can we put into little vehicles and just send them places? Fish
Yeah.
bots. Oh, good gracious. I think we've done it. Do we have anything else that we want to add to the list of 2022?
We
I
did
was
not
just gonna
include
say
COVID.
It's
We
we're just gonna get
didn't
in
include.
trouble, but-
Everybody had it.
Yeah,
I
everyone
just
had
to
it.
throw in one-
It's over apparently, but then there's still places in the red tier right now, so it's clearly not over. But vaccines happened, boosters happened. This is not really, we figured out it wasn't engineered in a lab. All good stuff.
We realized we should wear masks, but then
Yeah.
we didn't make people. So that's great. Justin, what were you going to add on?
No, I was just it's a nothing comment. I was just gonna say that the fish car
Yes.
shows because you always get like who got credit for landing on the moon? A bunch of pilots. Well, this fish car shows you how big of a difference you can have between pilot intelligence and the engineers that made the craft. There can
That's true.
be a little bit of gap.
Don't down talk fish intelligence now. I mean,
I'm not.
2022 was another year of animal cognition and animal intelligence in which we
was
saw
huge this
all
year.
sorts of cool things. We didn't talk about bees playing, which I'm
I
still
love that
debating
story
in my
so
own mind.
much.
Great story.
I loved it.
Corvids and different jay species and their intelligence, apes, and there was so much.
Lots of animals communicating through sound that we didn't know about before.
Communicating, yeah.
Just because we couldn't hear it because our hearing is not good.
The world is becoming apparent to us
Yes,
as we
I
ask
love
the
it.
right questions. Yeah. But I do think that we have gotten to the end of our show. Oh yeah, Paul Disney, the next step is to get some slime mold to pilot a spaceship to the moon. There we go. That's the
Well,
next
we
step.
got the watch. We got the slime mold watch, so we're on our
Yeah.
way.
You do have the slime mold watch. You're right. Slime
Yeah.
mold that tells time. Okay, everyone. We did it. We've counted down all the top stories of 2022 according to us and our review of the year. And yes, Patrick Pecoraro, no, we are not very choosy and specific. We like to be broad and graspy because, that's what life is. There's so many big picture things going on, and that's where our future is as well.
If you have issues with it, take it up with us on Mastodon because we don't know where it is.
That's right. Go find TWIS
And
Science on
it's
Mastodon.
tough
There you go.
because they always end up being these little categories now because we do over 600 stories a year now.
Yeah.
It's
So many stories. Yeah.
that you run with these themes that it's like, okay, well, there was like microbiome was a dozen studies that really caught our eye at some point during the year. So that's how come that's a category and not something else, I guess.
And like I said at the beginning of the show, like you can't very often, very, very rarely is it a single study that changes the direction of science.
Well, and we don't want
it
to just
happens, but-
re-report a single story. We already did that. We'd rather give
Yeah.
you the liner notes on like 50 to go look at later. So
Go
you're
check 'em
welcome.
out. You're welcome. We reviewed your year for you. All this happened and more. Whew. Thank you for being here through 2022 with us. It has been quite a year, another amazing year, and I feel so lucky to have shared it with all of you. Every week, no matter how down I am or whatever, whenever I have the chance to come here and talk about science, it reminds me of all the thoughtful, compassionate, incredible people that are out there in the world that are doing work to feed our curiosity and to help us understand this little blue rock where we live. So it's all about being with you all every week, except for next week because we're going to be taking a break. Anyway, shout outs to I'd love to say thank you to Fada for all your help on show notes and on the social medias. Thank you for helping with all that. Gord, Arnlor, thank you for helping to keep our chat rooms nice places to hang out. Identity4, thank you for recording the show. And Rachel, thank you for editing the show. And as always, of course, I must thank above and beyond our Patreon sponsors. Thank you to Teresa Smith, James Schaefer, Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazar, John Ratnaswamy, Carl Kornfeld, Karen Tazi, Chris Wozniak, Dave Bunn, Vigard Shefstad, Hal Snyder, Jonathan Stiles, a.k.a. Don Stylo, Ali Coffin, Gaurav Sharma, Reagan, Derek Schmidt, Don Mundis, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Gru and Bob, John McKee, Greg Riley, Mark Hessenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, John, blah, 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 Johnny Gridley, Remy Day, Flying Out, Christopher Dreyer, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Adam Mishkan, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, Tony Steele, and Jason Roberts. Thank you all for all of your support on Patreon. Did I put the wrong things on the screen?
Yeah. I didn't know how to break it to you midstream.
Oh, well, I got all the names. This is the video thing. You got the secret notes, everybody.
We shared the show notes. Uh-oh.
Shared the show notes. Oh my gosh.
Now they know we use yellow. Ugh.
Oh my goodness. Because it's a bright color and it grabs your attention. It makes you realize that you should be moving forward in the show. But anyway, thank you everyone for your support on Patreon. We really can't do this without you. So if you watching the show right now feel like you would love to support the show, head over to twis.org and click on the Patreon link and help us keep the show going throughout 2023 and into the further future. Help us get to 1,000 episodes. Let's do it. We hit 900 this year. Let's go up to 1,000. And oh yeah, on next week's show, Justin.
Well, next week's show we don't have a show, but the show after that,
I won't be here.
the week after that, we'll be back. Both two shows. One Wednesday, 8 p.m. Pacific time, and another one at 5 a.m. Central European time.
It's the same show.
You can join us on YouTube. We got the Facebook, and we also are always here at TWIS.org/live.
Oh, also that'll be our prediction show.
When we come back. Yes, 2023, the first week of January. Join us as we predict the future of science. Looking forward into 2023 and also looking backwards to see how we did about predicting 2022.
I looked and I didn't do well. Anyway, do you want to listen to us as a podcast? Maybe listen to some old episodes about some of the things we talked about today while we take the week off next week. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For any information on the stories that you heard here today, to go and read the papers yourself even, the links to the stories are available on our website, www.twis.org, where you can also sign up for something called a newsletter.
Yeah. You can also contact us directly. Email Kiki at Kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twis.org. Just be sure to put TWIS, TWIS, in the subject line, or your email will be spam filtered into a previous year and we'll never find it again.
Well, you can also hit us up on the Mastodon. Is it a Mastodon or a mammoth? What is it called?
Mastodon.
It is a Mastodon.
Universidon.
Where we are at TWIS Science. If you still say at, we'll figure it out. We'll have the young people figure it out. Where we are at TWIS Science, and that's it. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes during the night, please let us know.
Did we all drop Twitter and I missed it?
Twitter dropped Twitter. Didn't you hear?
Well,
Twitter stopped using Twitter.
Anyway. It's also at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. I'm still there sometimes, so if you want to tweet at me.
I heard the whole thing got hacked.
Yeah, we'll be back here in a couple weeks, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma.
Gondii-ay-yi-yi-yi-i. It's the end of the show.
My calendars, it's almost January.
Your calendars now. Head to twis.org. Very easy when you go to twis.org. Oh, is that the noise it makes when you go to twis.org?
Yeah.
Calendar noises. The calendar noises. They say, bye now. Thank you, everyone, for joining us for another episode of TWIS. I think we have done many top 11 countdowns now. It's great to have another one under our belts. Click on those links, everyone. Get your 2023 TWIS calendar, digital download, or on Zazzle, physical calendar. Our show is not scripted. I mean, there's little scriptings, but still. How is everything, Blair? We made it.
We made it.
Yeah. We made it through another episode of TWIS.
It's the sleepiest day of the year today.
It is. I didn't mention that at all. Yeah. Happy solstice.
Mm-hmm. Indeed.
It is the 21st, and I've been looking forward to. I'm like, I gotta say something about the solstice, and of course I didn't. I love the solstice because
So good.
the darkest, longest night, and of course it's like at the same time that here in the northern hemisphere, North America, there's a bomb cyclone going off, and places are colder than they've ever been, and it's freezing.
Winter solstice, it's literally the reason for the season.
Reason. Can we start getting warmer now?
Yes, officially tomorrow.
Yes, let's tomorrow start getting some longer days, some different. Oh, you're sick, Fada. I'm so sorry. Get a good night's sleep. Yes, Paul Disney, you're not doing well. You're cold and it's dark. I know you want a nap. Everybody should just go to bed. Oh, we've got a Justin back. So, I removed him. Sorry. You and I will fight each other. He's on, he's off. He's on, he's off. Everyone, yes. So, Justin, people were asking earlier in the show why you weren't wearing a t-shirt.
Why I'm not wearing a t-shirt?
Yeah, they were very confused by the collar.
Oh, it's just cold. It's just
I believe
cold
they
here.
called you dapper or something like that.
Oh, thank you. So I'm just dressed a little more warmly right now because the heater in this motel I'm staying at sounds like people are drilling through the wall.
Oh gosh.
It's so I have to kind of like, well, a good night's sleep where I shiver all night, or is it a good night's sleep where a droning drilling sound is all night? So it's kind of
sounds like a great choice.
Yeah, usually what I do is I crank it up and then leave and go do stuff and then come back and just turn it off and it's fine.
Yeah,
but
smart.
I forgot to do that earlier.
Well, it would have been loud during the show, so.
Oh, and I had to have it off during the show, obviously. Yeah, but
yeah.
So it is a little chillier in here than other days, but.
Oof. So it's going to apparently get down to 19 degrees here in Portland tonight. That's cold for Portland. Yeah, Paul Disney saying it's 24 degrees in Seattle right now. We're actually a little bit colder here in Portland at the moment.
That's nothing.
But I know
it's
that
only 40. It's 41 here. I shouldn't be complaining at all. My goodness.
It's cold.
Oh yeah, low of 38 here.
Yeah. Of course, the room is set to 41. So that's
there's the difference.
Why I'm complaining.
There's the difference. Yeah, we have people who are in Northeast Washington and other states who are going to be getting really cold over the next couple of days as it gets into single digits, maybe negative temperatures. And so I hope everyone is able to stay warm, that your power stays on, that you've got all you need in terms of holiday warmth over.
Yeah. Great time to get, some years maybe, giving a gift of a scarf isn't as appreciated as others.
It would be appreciated.
It'd be a good stocking stuffer this year.
Socks, hats, scarves. Yes.
Well, the other thing I'll say too is like this is a good reminder that when it gets really cold, people burn wood a lot. And if there's not a lot of precipitation to go with that cold, then air quality can go down the toilet. So that's what's happening right now where I am, is that it's been a spare the air day like every day this week, and the air quality has been an AQI of like 80, which for the middle of winter is pretty high. And it's because everyone's burning their fires. And for my house, that's true. My house heats up better if I light a fire than if I turn on the heat.
Weird.
So,
Yeah, that is weird.
well, I don't have central air, so I just have the wall units. So it does.
Yeah, those are great if you're standing in front of them.
Yeah, exactly.
Perfect
But
if you're
the
standing in front of
fire
them.
or the oven, those two things heat up the whole house. So, but yeah, that's something to keep in mind. Check and see if it's a spare the air day where you live, and
don't use your oven to heat your house. Carbon monoxide is a real thing.
No, don't do that either.
And hey, and this is just a side note. Hopefully it wasn't too much going on during the show, but I keep hearing that clicking.
Mm-hmm.
Yeah, it's gone a little bit. It was on
It
and
only
off.
happened a couple times. I think.
Yeah. It happened for a little bit where I hoped that it would stop, and then I muted your mic other times, and then you started muting your mic, and so it was fine.
It doesn't seem. I don't think it's my mic. I don't think it's this end. I could be wrong, but
I think it's the mic, because it's whenever I'm talking or Kiki's talking, I feel like it's happening, and so I think it's exactly what you were asking before. If there was an echo, it's not an echo. It's sound cancel. It's noise canceling the echoes, but it's turning into these little clips. So I think if you have headphones next time, it'll be fine.
Yeah, we'll see. Yeah, no, I do have access to some headphones that would work on this. Except then it also needs to be plugged in, so I don't know how to do that.
You have to split it. You have to go to that big scary store with all the windows and people all dressed the same.
No, you don't.
No cash registers.
No, you don't. Go to the internet. The internet is the place.
I mean, you could do that too. I just always am afraid of my Apple product catching on fire when I use cheapo versions of things. You notice that if you use like a super off-brand charger, sometimes your phone or the charger itself will get crazy hot.
Yes.
So
Anchor is a pretty good brand, but it happens a lot. 11 in Anchorage. Wow. That's just probably going to get colder too, Eric. Stay warm. Stay warm, everyone.
Eric, I demand to know, how often do you see moose? I'm waiting. I really want to see a moose in the wild before I die. I really want to do that.
Not up close, but close enough.
Close enough. I saw elk up close enough. On my road trip. That was really fun. We saw a bunch of Roosevelt elk. They're so cool. Oh, they're beautiful.
Where was that road trip? Was it up the coast?
Yeah.
Yeah.
There's this one area north of Humboldt County, just north of it, just as you're leaving, where there's a big community of them. And I had never noticed it, and I was on this trip, and I saw the sign, and I went, "Oh, that's a joke. There has never been any elk around here."
Elk Meadow.
Like, 100 yards later, they were like all over the side of the road. And I was like, "Oh, wow, that was very wrong." But I lived up in that area, south of there, for years.
You got to go just a tiny bit more north.
Just a little bit north, and they're all over the place. It was crazy.
Yeah, they're like, we don't want to mess with the town. We just want to be up here. Hang out in Fern Canyon.
All right, well, I think we did it.
Fern Canyon.
Yeah.
I think we did it. Another
we
great
did it.
Recap for another great year of TWIS. And our next show, which is not next week, of course, we reiterate.
Say Happy New Year, Justin.
Happy New Year, Justin.
Yeah.
Say Happy New Year, Blair.
Happy New Year, Blair.
Happy New Year to you, Kiki.
Happy New Year, everyone. Merry Twistmas. Happy solstice. Happy, Festivus, Krampus, whatever it is that you enjoy to celebrate over the next couple of weeks. Please take advantage of the opportunity to think about all of your time and our amazing opportunities here on this planet, in this life. And we will see you in the new year with our predictions. I hope that you have a wonderful next 2 weeks. All of you have a really great time. I hope to see you online. But yes, Merry Twistmas and a Happy New Year. We'll see you in the new year. Thank you for joining us once again for our top 11 countdown. We can't do this without you. Thank you so much for joining us. Good night.